Hi everyone. I hope you guys are enjoying the sessions so far. I'm Nicholas Jyrwa and I'll be teaching you, or rather, I'll present to you a topic which is very much feared in our lives. Numbers. Does it ring a bell? I'm sure all of you at some stage in your life must be fearing numbers. But today we'll talk about magic of such kind of series of numbers that will actually amaze you because it talks about these numbers that have transformed in every part of our lives. Let's begin. We start off with what these numbers are, and they're actually your Fibonacci numbers. So, what basically are Fibonacci numbers? So, let's begin with a story that you want to plant a seed and you water it, and as you can see, a shoot grows. You water it some more, and then another shoot grows. All right, you fertilize it some more, and then you'll see that two shoots appear. Water some more, and then probably, or rather, mathematically, you'll see three shoots appear. As you go forward, these three shoots change into five. As you water it, you manure it enough, they change into eight, and probably with a lot of care, you get 13. Do you know how many shoots will you get after this? Now that's the thing that you need to answer. So if that is what is if you are to guess what is the next number after this, for those of you who know a little bit of this will actually change to 21. Now, how is this? Why these numbers appear? How did these numbers come into being? So, what exactly happened was, oops, sorry. So, what exactly happened was, we take 1 and you add 1 to it, you'll get the number 2. Add 2 to the previous one, you get 3. 3 to the previous 2 is 5. 5 to the previous 3 is, what is it? It obviously is 8. 8 to the previous 5 becomes 13, and so on and so forth. Okay, these are what basically are your Fibonacci numbers. Okay, so that becomes 34, and the list is in front of you. Now, who discovered it? Obviously, since we say it's Fibonacci, it must have come from Fibonacci, right? So let's talk about a little bit about Leonardo of Pisa. Okay, so he was actually Leonardo, and Fibonacci came after he developed this series. So who was he? So he was born in Pisa in 1170. Pisa is in Italy. The only interesting thing about that town is basically the Leaning Tower. All right. Apart from that, obviously the fellow Leonardo himself. His father, Guglielmo di Bonacci, okay, sorry for my pronunciation, was a merchant, and he actually wanted him to become a merchant. But during this time, when he basically was a merchant, he studied, and he studied under Muslim teachers, okay, a Muslim teacher who actually taught him the Indo-Arabic numbers, which is basically the base of your decimal numbers today. And in those times, he had not yet introduced, it was not yet introduced in Europe. All right. So for the next 25 years, he did a lot of research. He published a lot of mathematical manuscripts. Those are some names of the Liber Abaci, Practica Geometria, the Flos, the Liber Quadratum, okay, which are known to us today. And for his dedication to mathematics, he was actually awarded the title of Discretus et Sapiens Magister Leonardo Piccolo. Okay. So have a look at this pine cone, and if you look at the pine cone, I'm taking an example. Okay, you'll see that the number of spirals, okay, that's 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, all right, and 13. That is nothing but your Fibonacci number, all right? That's with a cone. If you have a look at this plant out here, even this plant has 5 spirals. See, look at that. That's 1, 2, 3, 4, and 5. 5 is actually a Fibonacci number. Not only in plants, but we also see Fibonacci numbers in a human body. If you take the X-ray of your palm of your hand and you look at the wrist, the bones in your fingers rather, the length of each bone of your fingers is in series, which is your Fibonacci series. Your body is always divided into 3 segments, which is your medial, your proximal, and your distal. Your fingerprints always follow the Fibonacci series. Okay? Now, Fibonacci discovered that if I had to make a kind of a square and build it on basically on your Fibonacci numbers. So there you go, 1 and 1, and then you make a square of 2. Then it becomes a rectangle of 3. 2 plus 3 becomes 5. Okay, and then 8. 5 plus 3 is 8. 8 plus 5 becomes 13. 13 plus 8 becomes 21. And obviously 21 plus 13 becomes 34. Okay, you might be wondering, what is this box all about? What am I doing with all this? These rectangles and square. But this is where the beauty lies. Now, if I draw a curve which is touching the so-called lines at the tangents, if I draw a curve like that, as you can see, you won't believe this, but this is what is the relationship between any picture that you know, the best pictures in the world, they always follow the spiral diagram. Okay, and they say the best photographers in the world actually follow this, the spiral diagram associated with your Fibonacci series. Wonderful, isn't it? Okay, but that just stops there. What else do we have? Let's go ahead and see. So we were talking about this, the spiral diagram. Where would you have seen this? Give it a thought. Okay, and if you actually give it a thought, the first picture that comes into our mind is actually the Milky Way, the galaxy. It follows the spiral, which is actually nothing but a combination of the series, the Fibonacci, the famous Fibonacci series. The egg, have a look at that. Your egg, the egg that you eat, the shell out there, okay, it follows this spiral theory. Your DNA, this is your cancer cells, the DNA out there, they follow the Fibonacci series pattern. The tail of a chameleon as well follows that. And let's not forget, if you are into, if you like to see the weather, you always like to see basically cyclones and all. What do cyclones, how do they move about? Just have a look at that. Again, they follow the spiral diagram of the famous Fibonacci series. In fact, there was a statistician, he actually talked about the population density of the African continent. And believe it or not, this again followed the famous spiral diagram of Fibonacci series. So what are the results? Let's have a look at, if you divide these numbers, what do you get? What do you get if you divide 1 by 1, 2 by 1, 3 by 2, or the other way around? So this is a small graph that I prepared, and if I divide, as you can see, 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 2 is 1.5. And as we go on, we see that you get the numbers 1.6, very close, 1.6, 1.6, okay? 1.6. If you go on the reverse way, you'll also get 0.6, as you can see out there, 0.61, 0.619. Okay, so what are these numbers? Why am I dividing this? So this will actually, it was a big breakthrough, and it's either 1.618 or it's either 0.618. And what does this talk about? It is basically your golden ratio, ladies and gentlemen, and what it is exactly or approximately equal to this number, 1.618033,988 7498948482. And it goes on. How do we understand this? We understand this. Let's take a line. And if your line is broken up into two segments, A and B, if you add them up, it becomes A plus B. So if you take the ratio, of this, okay, that's your ratio. B by A is equal to A upon A plus B. And we cross multiply it. We get that as an equation, and we substitute the value of B as 1. And when we solve for A using quadratic equations, we get the value of A as that 1 plus square root of 5 by 2. And the Greek letter, ladies and gentlemen, this is your phi. It's called as phi, which the value is that. So why do we use phi? Where do we use phi? This is where we use phi, which is called as your golden ratio. And any picture, for example, the famous Mona Lisa painting, this basically has the perfect golden ratio, 100%. Okay, 1, and that is 1.618. Perfect. Okay, Leonardo da Vinci could not have been wrong in actually drawing this perfectly, though he may have not known what is Fibonacci numbers, but he knew. Can you imagine what talent he had? Based on this, if some of you would actually tell me who is the most beautiful woman in the world, well, if you actually had Aishwarya Rai, or if you actually thought it was Kate Winslet, then you're absolutely wrong, guys. Absolutely wrong. Okay. We have Miss Belal Hadid. She is exactly or nearly 94.35%, very close to the value of phi. All right. So just a small joke. If you are married out there, guys, make sure you measure the value of phi of your respective wives. You may never know. She might be quite close to phi, the value of phi. So in the end, ladies and gentlemen, maths is not always to basically, find the value of x. Never, always. It's always to find the value of x. Sometimes we also need to find out y. Figuring out y is as important as finding x. Thank you very much. I hoped you liked the presentation. Good day.